So now, class, let us discuss about the solutions of oblique triangles. So an oblique triangle is a triangle that has no right angle. Also, it is a triangle whose angles are all acute, or a triangle having one obtuse angle. So as you can see, the figure in the left side is an oblique triangle having acute angles, and the figure on the right side is an oblique triangle having one obtuse angle. A triangle has three angles and three sides. So given three principal parts, at least one of which is a side, we can possibly find the measures of the other three. Adequate methods for solving oblique triangles can be used, such as the law of sines and the law of cosines. Any type of problem involving the solution of triangles is covered by one of these methods. Any type of problem involving the solution of triangles is covered by one of these methods. So we have here the conditions that determine a triangle. To solve an oblique triangle, you need to know the measure of at least one side and any two parts of the triangle, either two sides or two angles, or one angle and one side. So this breaks into four cases. So we have the first one, two angles and any side, or the AAS or ASA. Two sides and an angle opposite of them, or the SSA. Then three sides, or the SSS. And two sides and their included angle, or the SAS or SAS. So here, the first two cases can be solved using the law of sines, whereas the last two cases require the law of cosines. So 1 and 2 can be solved using law of sines, and 3 and 4 can be solved using law of cosines. So in case 1, given the two angles and any side, we will use the law of sines. The law of sines states that side A over sine alpha is equal to B over sine beta, which is also equal to C over sine gamma. So let us see how the law of sines was derived from our trigonometric function. So in an acute triangle, if we are going to focus on this triangle, we can see that the opposite side of our alpha is H, and so with the opposite side of our beta. It is also the same with the obtuse triangle. A over sine alpha is equal to B over sine beta, which is also equal to C over sine gamma. So let us take an example. Solve the triangle A is equal to 3, B is equal to 2, and alpha is equal to 50 degrees. So in order to find the missing parts of the triangle, we will use the law of sines to find, first is the beta. So in solving for our beta, we know that A over our sine alpha is equal to B over our sine beta. Substituting the values of A, B, and our alpha, that is 3 over sine 50 degrees is equal to 2 over sine B. So in order to find sine B, we will cross multiply the equality. So that is 3 sine B is equal to 2 sine 50 degrees. So para matira yung sine B, we will divide both sides by 3. So sine B now is equal to 2 sine 50 degrees all over 3. And our sine B now is equal to approximately 0.51. So in order to find beta, we will take its sine. So sine 0.51 is approximately 30.7 degrees. And we can now find the measurement of our angle gamma by simply subtracting the measurement of our alpha and beta in 180 degrees. So 180 degrees minus 50 degrees minus 30.7 degrees is approximately 99.3 degrees. That is now our angle gamma. Now to find C, we will use C over sine gamma is equal to A over sine alpha. So substituting the values that we have got, that is C over sine 99.3 degrees is equal to 3 over sine 50 degrees. So using cross multiplication, C is equal to 3 sine 99.3 degrees all over sine 50 degrees, which is approximately 3.86. So these are now the measurements of the sides and angles of the triangle. You can also check the examples in the module that I have sent regarding the law of sines.